Good afternoon, everyone. Today we're going to find the equation of a line segment running from point A at -2 and 1 all the way to point B at 5 and 8. And then we're going to find the length of this line segment. Okay, so just to give you guys a visual of what we're doing here, we have a line segment running from the point A at -2 and 1. You know, that's somewhere around here. A at -2, 1, all the way to point B at 5, 8. Let's maybe make that, I don't know, somewhere around here, point B at 5, 8, and we have a line segment joining the 2 points, okay? Now, this is gonna work the same as a line that would run in both directions, infinitely in both directions, but we're just gonna cut it off at points A and B, okay? So, first thing we can do whenever we have 2 points is we can always find the slope of the line. So let's start off with that. Our slope is found by the change in y over the change in x, as you know. And so that means we're gonna have 8 minus 1 over 5 minus -2, which is 7 over 7, which is 1, conveniently. And we don't have the y-intercept, we could find it. But we have 2 points to choose from, so we could conveniently write this equation in slope point form, since we have the slope and 2 points to choose from, and we can choose either point to write our equation with. Let's choose point A, just by happenstance, or rather, just arbitrarily. So, in slope point form, we're gonna have y minus the y coordinate, so y minus 1 is equal to the slope, 1 times x minus the x coordinate, minus -2 means plus 2, right? Subtracting negative means positive. So here's our equation. And now, if we want to write this in slope-intercept form, we can happily do that by multiplying through the brackets, and then we'll have y minus 1 is equal to, that's just x plus 2. And then, of course, in the idea of isolating the y to get y is equal to x plus b, we add 1, of course, to both sides, and so we get y is equal to x plus 3. Okay, and that's our line in slope-intercept form, right? Slope-intercept form, and so that is the equation of our line segment running from point A to point B. And now, if we want the length of it, that means the distance between points A and B, right? That would be the length of the line segment that joins them. We can find this length by doing the square root, right, from the Pythagorean theorem. You can imagine that we can construct a right angle triangle, right, and then apply the Pythagorean theorem. A squared, A being the difference in their x coordinates, and so the difference in their x coordinates is going to be, let's do 5 minus -2. And it's a squared, right? The Pythagorean theorem is a squared plus b squared is equal to c squared, as you know. And so we need this length squared plus, let's make this a bit bigger, and we would use b, the vertical side length, which would be the difference in their y coordinates, right? This y coordinate minus this y coordinate, so that'll be 8 minus 1. And again, we want b squared, and so we have to square all that, and that would be equal to c squared, right? And so to just get c, which in this context is the length of this line segment, we take the square root of both sides, and so we're left with a line segment having a length of 5 minus -2, that is 7 squared, plus, again, 7 squared, which means we have the square root of 49 plus 49, which is 98, and we can leave it like so. We can even simplify this radical a little bit, because 98 is 2 times 49, right? So that's root 49 times root 2, and root 49 is 7. So this length is 7 root 2. You can write that as a decimal if you'd like, but that's an irrational value, and so I would leave it as radical of 7 root 2. And we're done. So I hope this helps. I hope this connects some dots with some linear equations and some distance equations, or rather, distance of a line. Thank you for watching, and that's it.